Here in session 88, polynomial functions is what we're going to be looking at and actually graphing here. Just as a quick review, what we have here is a linear equation in standard form, ax plus b equals 0. In our second example, what we have is a linear function. We still have our ax plus b on one side of the equation, but instead of a 0 on the other side, we've inserted a second variable y. And remember, what this does now is this second variable y is dependent upon this first one, x, and as x changes, so does y. There's a relationship between the two. In our first example of a linear equation, at most what we're going to have here is one solution to this equation for a linear equation. For a linear function, however, we have introduced the likelihood now of infinite number of solutions. As x changes, so does y. But for up here, what we're going to have is just one value for x. That is, when computed in this formula, it'll give us, or this equation will give us 0 for a solution. The same is true of a quadratic equation compared to a quadratic function. Quadratic equation in standard form has just one variable in it, x, and it's in the form of ax squared plus bx plus c equals 0. And in this case here, at most, this quadratic equation is going to have two solutions. But when we've introduced our second variable now, y, and made a function out of it, we still kept our ax squared plus bx plus c on one side of the equation. But on the other side, in place of 0, we've placed y. So now what we've introduced here are an infinite number of solutions here, or points, whereby x's and y's combine together to produce a function that's equivalent to each other. A quadratic equation has at most two solutions, whereas the quadratic function has infinite number. Linear equation at most one solution, but with a linear function, you now have an infinite number. Here on the second screen, what we have is a quadratic function. Well, we have quadratic because our largest degree for our x variable is a 2. It's to the second power. That's what makes it quadratic. And on the left-hand side, instead of a 0, we have a y, our second variable. That's what makes it a function. If we had a 0 in its place of y, and we just had 2x squared minus 4x plus 4 on the right, we would have an equation. Here we have a function. What we'd like to do now is to graph this function. And just as we did with linear functions, it's oftentimes helpful to create a table. So I'm going to go ahead and choose 5 values here for x. And oftentimes, it's good to choose negative integers, positive integers, and then also the number or the integer of 0. So that top part of our table is going to represent our x's, and the bottom part is going to represent our y's. So then, when x is minus 1, what's y? Well, let's put minus 1 back up here and calculate it out. Minus 1 squared is positive 1. 1 times 2 is 2. Minus 1 times minus 4 is positive 4. 2 plus 4 is 6. 6 plus 4 is 10. So when x is minus 1, y is 10. Let's put a 0 in for x now. 0 squared is 0. 0 times 2 is 0. 0 times 4 is 0. 0 minus 0 is 0. 0 then plus our remaining 4 is a positive 4. X is 0. Y is 4. X is 1. 1 squared is 1. 1 times 2 is 2. 1 times 4 is 4. 2 minus a 4 is a minus 2. And a minus 2 plus 4 is a positive 2. When x is 1, y is 2. X is 2. Place that within the formula and calculate it out. 2 squared is 4. 4 times 2 is 8. 2 times 4 is 8. 8 minus that 8 is 0. 0 plus 4 is 4. So when x is 2, y is 4. And lastly, for 3, 3 squared is 9. And 9 times 2 is 18. 3 times 4 is 12. 18 minus 12 is 6. And 6 plus 4 is 10. So when x is 3, y is 10. At this point now, let's go ahead and plot these points onto our graph. Our first one is minus 110. So we come to our origin and come left minus 1 and then up 10. 5, 6, 7, 8, 9, 10. There's our first point. Our second point is 0, 4. So we start at our origin, x is 0, and then up 4. Our next one is 1, 2. Come over 1 to the right for our x of 1 and up 2. That's our y. Our next point is 2, 4. So over 2 and up 4. And then our last one is 3, 10. Start at our origin, come over 3, and then up 10. So here are 5 points that are on this graph. And as you remember, the graph of a quadratic equation, or a quadratic function, I should say, is a curve. And in this particular example here, the curve is going to have 2 sides to it. It's going to go downhill like this on the one side, and it's going to curve up like this uphill on the right-hand side. And I actually missed my point there. So let's go ahead and redraw that again. Try to hit my points a little bit better. Not perfect, but you get the idea. This particular type of curve for a quadratic is called a parabola. That'll be more on that later on in algebra. But we have a curve here, downhill on the left for this particular one, and then uphill on the right. So this then is the graph for a quadratic function. And once again, as a review, to graph a quadratic function, simply make a table, choose some values for x, and it's usually helpful to choose consecutive integers and to choose them such that you include some negative integers, 0, and some positive integers, and then place those values as well as their corresponding values for y into that table, then graph the function by using those values from the table. Lastly, graphs of quadratic functions, which are functions whose largest variable is to the second degree. The graphs of those quadratic functions are curves. That'll finish up then session 88 on the polynomial functions.